How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have some replacement parts to do for a customer's 631G scraper. So the parts we're going to be making are the mounting plates for the guide rollers on the back of the ejector door. The way an ejector door works on a scraper is the door is usually all the way back when they're loading. So that big cylinder will draw back, creates a big void in the front of the bowl. When they drop their bowl into the ground, it then loads itself by the propulsion of the machine. They pull down the apron door, lift the bowl up in the air, and away they go to their next part of the job site they want to fill. Once they get there, they flick up the apron door. The ejector door then uses that cylinder to push all the material out the front of the bowl. Then they'll retract that once it's empty, pull the apron door down, and carry on to the next cut. So we were lucky enough to be able to come over to the customer's yard and show you exactly where these parts live on the machine. Where we are right now, we're in between the two back tyres. These two rails here is what holds the ejector door from tilting forward or backward when they're pushing out a load or they're drawing the door back to then take on a new load. Mounted to the plates we're going to be fixing are a set of wheels and a set of offset pins that can be turned to allow pressure to be pushed against the two rails. What happens is the bearings fail or the wheels jam and they end up chewing everything apart. So they do a lot of damage. They generally fail by rocks that might get flicked off from the back tyres. They get caught, they lock everything up, then they start to bend and break everything. The mount is a part of the original casting on this back part of the ejector door. When they wear out, the easiest thing to do is just to cut them out and put some new ones in. It is pretty important to get them in the right spot. We have designed a replaceable part that is very simple and very easy to fit to the machines, so it can be done very, very quickly on site. The way these come apart is you undo the locking bolt, which clamps the axle of the rear roller together. You then turn the wheel around, and if you look on this one, the wheel has a flat spot on the bottom of it. You turn that wheel and you can then pull it past the rail. So you do have an offset axle inside the bearing, and you just turn it, lift it up out of the road, knock the axle down, and you can then cut out the old part, set up your new one, and weld it back in. It's quite quick to do this. A guy I used to work with, he and I used to do these during a smoko break on a job site. One mechanic comes in, pulls it all apart, I come in behind him, cut it out, cut the other side, weld some new ones in, he puts it back together again. So the machine's not down for very long. These parts I will be making are ordered to go out in the field and be fitted on site. Nice, quick, easy way to repair a problem that would otherwise be an absolute nightmare. This machine's still in pretty good shape, but we thought we'd just show you exactly where they were, as it would have been quite difficult to explain this standing in the workshop. Righto guys, so we're back at the workshop. We've got 4 of these mounts to manufacture, so I've got 4 bits of plate here. We had them pre-cut in the container ready to go. The plate is 50mm bis 80, so the first thing we need to do is we need to grind all the mill scale and everything off them and just clean them up before we go and set them up in the milling machine. Righto guys, so because these are a flame cut part, it's going to be pretty hard to get a reference of level from the top of them. I mean, I can just run my hand through that and feel that the sides are quite nice, but the top has a bit of a lump in it. We always get a little bit of extra material on the parts so we can then trim them up to the right size. Now that I've got them set up and they are sitting pretty well parallel with the machine, I will face the top and the sides of them, and then that will be our reference for the rest of the measurements for the rest of the job. Righto guys, so what we need to do now, we need to find the center of the job. So I'm gonna use an edge finder. What's down the bottom here is actually also up the top. They are two perfectly machined faces that works on, and there is actually a spring inside that holds the two parts together. What's gonna happen is I'm gonna move the job up against this edge finder, and when it slightly kicks off to one side and stays there, without wobbling around it, that is the true edge. I then use my DRO, I zero that out, come over the other side and do the same thing. Divide that by 2 and there's our center. So I've just discovered there's been a problem with the cutting on these parts. The hole is not where it is supposed to be, but it is going to clean up where it needs to. We'll still get the job done. It's 1.28, so I've got 0.9 of a mil to come off. guys, so we've completed the boring for the holes where the pins need, the axle or the pin need to go. What we need to do now is machine a 45-degree bevel on both sides of it around the back radius for the weld prep. We've set the head of the milling machine up on a 45-degree angle. We're going to use our rotary table to hold the part using a 3-jaw chuck that's attached to the rotary table. We've got a 25mm indexable end mill in there. We'll use the table to rotate the part around the cutter to cut the bevel. Right, so now what we need to do, we need to cut some slots through the plates. That's going to allow room for it to be clamped onto a pin. So what we're going to be using is our horizontal milling attachment. When we're using the horizontal attachment on this machine, you do have to run the 90-degree head because it doesn't have a horizontal attachment or motor or spindle coming out of the machine. This machine's bigger brother does have the horizontal spindle in it, but the issue with having a horizontal spindle, you can't put riser blocks in your machine to lift the turret higher. So I've got 2 riser blocks. I can lift this head another 150 mil if I wanted to, and you couldn't do that if you had the horizontal attachment in your machine. To have the versatility of a larger capacity machine without spending an extra 50 grand, this is by far the best way to go. And using the 90-degree milling head is the reason this doesn't have an air drawbar. We're going to be using a 5/16 by 4 inch milling cutter, more commonly used for keyways and slotting. Because my slitting saw blade that I wanted to use is blunt, I'd have to do 2 passes with that to get the 8mm gap, where in this case I'll just use the 1 cutter, full depth of cut, pass it all the way through. It should be good. What's in here?
Gift.
Homeless. What's this? Oh. Made in the USA.
Yummy.
This. Righto guys, we've completed all the machining on the plates now. We do need to get these things packed up ready to go because they're going about 400 k's northwest of here. Customer's got a machine down at the moment. When these are being fitted into the machine, depending which machine it is, if it's a 637, that's a twin drive machine, so engine in the front, engine in the rear. It's very, very difficult to get to these. Best way to do them is when the door is all the way forward and then you've got access to them. But the last one I had to go on site and do, the door was fully closed and it was full of dirt. We had to take the rear tire off to get access in to get to there. The 31 series machines, they don't have an engine in the back, so there is a bit more room in the back of the machine to work on these. We have two ways you can cut these old parts out to then fit the new one. I do supply our customers with a centering plug that has a center hole in it. They can then use a oxy torch with a circle cutter to find the distance from the outside, cut all the way around. Nice, quick, easy cut. And you can do that when there's heaps and heaps of room in the back of the machine. But when you're very limited for room and where the bin is full and you don't have any access, you can then come in from the top with a straight cutter and the same sort of thing. Because there's a bit more room above you than there is around you to be able to cut that part out. And then all this material that I removed here, that is the weld prep. So providing they do a really clean cut when they cut the old one out, this is simply just put straight back in place. It can't go in any further if they've cut it correctly. They simply tack it on and weld it out. Once these are welded into the back of the ejector door, the pin that goes down through this hole and holds the wheel, it has a recess machined into it. That's why those bolt holes dissect the pin hole here. This bolt falls into that recess that's machined into that pin. They tighten up the bolt, that squeezes the mount closed and it grabs a hold of that pin. Nothing can move, then they do their adjustments they need to do. So with all these completed now, we're going to get them packed up and get them sent away so our customer can get his machine back to work. Any cookie on my face, man?
Nope.
No? You're recording, aren't you?
Yep.
Righto guys, so we're back at the workshop. We're back at the workshop. Oh, fuck, man.
Where are you going with that?
I don't know. So we're gonna... Fuck, now I've lost it. Oh, fuck. Right. Oh, fuck. Fuck, I lost it. Yeah. Oh, there's something horribly fucking wrong there. Hey mate, what's happening? Fucking train.
You mean the one on there?
Similar. And it's fucking grown legs and fucked off again. There's a hole through the vice through the bed. Fuck! I'd scrap the machine.
What?
Oh man, piss me. That'd just burn my piss all day long.
Does it have to cut all the way through that? Yeah. Jesus. It's tinsel. Workshop tinsel.
It's extremely sharp and terrifying tinsel. Wouldn't want that hanging on my tree.
Oi! Bring it here.
Bring it here.
Poor pig. That's it crying. Help!
Help!
Bacon flavour.
Mmm.
Oh. Any more pics?